Hello everybody. Today we'll talk about the adaptive query framework. This is introduced in Spark 3.0. So let's understand this framework. So adaptive query framework is more like a re-optimization technique. So let's go to the gray diagram. So here we submit an application into the driver. Driver will convert that application into jobs, job 1 to job n. Each job will have different stages, stage 1, stage 2, stage n. These stages may be in sequential, may be parallel. Then stages will have tasks, task 1 to task n, and these tasks are going to run in the worker node. So within the worker node you will have executors. So once we talk about the sequential stages, so there may be a scenario outcome of the stage 1 may be a input for the stage 2. So this is the area, fault area, where we have the opportunity to re-optimize the query, and that can help us to utilize the memory and process the query fast. Before we go into the adaptive planning, so let's understand the logical and physical plan. Let's say left hand side, we start from the SQL or data frame or data set. We are submitting that. Initially, once we submit, that is a unresolved logical plan. So this is your unresolved logical plan. So basically in this time, we are not able to identify the table name, what are the columns we need. So those are not resolved. Then it will pass to the analyzer. So analyzer, what it will do, it has the catalog, it will use the catalog metadata, all the catalog it will use. High meta store example, where you will see your table names are there, column names are there. So all these table name and columns will be resolved. So then we'll create a resolve logical plan. This is the next step. Once we resolve table name and column names, then we'll pass this to catalyst. So catalyst, what it will do, it will run different kind of internal rules. Those rules may be, let's say, filter push down. We have some condition to pay filter. Idea here is that to reduce as much as data load possible and process the data fast. So it will identify, okay, these are the filter we have to put in early. So filter push down will be there. Second option is that we have to apply rules projection. Let's say, for example, I need these number of attributes or field just for outcome. Just focus on them. So these kind of analysis catalyst optimizer will do based on the stats, and then it will create a kind of tree and function for the execution. So this is your logical plan. So logical plan talks about the output attributes, what are the attributes we have to display, project, what are the conditions we have to apply, describe what is the computation, what part it will take as a logical plan based on the stat. All these stat we are using static. So now, after that, what happens? Transformation will come in picture. Transformation engine will transform this into the different physical plan, plan 1 to plan n, and then we'll apply a cost model. So because we have all the stats available, how many number of rows are there in the tables, how many null values are there, what is the maximum, what is the minimum, what is the distance in each attribute and field, those information we have already. We'll pass through that cost model. So let's say take example here we have table 1 and table 2. There are two tables. Table 1 have very minimal data and those two tables have to join. So maybe we are selecting broadcast join based on the stats. So then we'll select a plan number 3. Okay, let's go to plan number 3. We have to execute. So then what will happen? So basically we are saying that physical plans talks about how part and logical plans talks about the what part. All these things are happening based on the stat what we have right now. And then we'll create a RDDs. Those RDDs will go into the submitted into executor and they will perform the operation. But what is the drawback here? The drawback is there. First thing is that we are taking all the static stat that can go wrong, right? If they can go wrong, then we'll end up with hint. If a hint is going wrong, we are going to end up with wrong physical plan. That can take more time to execute a query. It will not utilize properly memory, right? So think this way. Let's say, for example, all the stats are pre-calculated stats are good. But what about the UDF, user defined function? Those are black box. It's very difficult to apply those stats, right? So what if, come up with the alternate approach? What if once we submit a job into the executor, let's say, for example, we have different stages. Stage one, that's where we previously we talked about. Stage one outcome is important for the stage two. Then I have, this is the area where I can use the re-optimization. I can resubmit after, because that at that time I will have live data. Based on the live data, I will submit that again on the logical plan. Again, logical plan will run based on live data. It will run the physical plan cost model. Then it will give a right query plan to execute on the machine. So what will happen that way, we are going to reduce the memory. We are optimizing code. It is running fast. It is executing completing on time. It is saving cost. CPU cycle, it is saving CPU cycle, that is translating into the cost. So this is the adaptive query plan framework. Basically what is saying that re-optimization, any failure point between the stages, if there is a dependency between one stage to another stage, let's re-optimize that time and run logical and physical plan again and again for different stages. Then you will get a efficient query run. So this is your Spark AQ framework. So next example, here we are talking about the breakpoint. Let's say in this example, I have to select two columns. Let's say for example, I have employee table, and employee table, I have the column one. Let's say for example, I have salary. I want to do group by salary, 5,000, 10,000, 15,000, that kind of group I'm creating. Column two, I have the age of the employee, that I'm doing order, increasing order, suppose, right? So basically what is happening in this case, so order I am doing based on the age, I am grouping on the salary. So that will give me the result what I am looking for. But here the thing, we have this query is we are running two stages. Let's say for example stage one and stage two. Aggregate scan table scan is happening, then aggregate function is happening, and then we have the shuffle, and there is a breakpoint after that. This is the breakpoint I have to re-optimize. Run again logical and physical plan to come up with the more optimized version, and then again apply aggregate for the stage two and shuffle and sort. So that's where adaptive query plan comes in picture. Re-optimize your code as much as possible and come up with the fine logical and physical plans which are going to run in the server or the executors. I hope you understand framework, and thank you for watching. Please subscribe.